12 minutes after takeoff, a bomb-like explosion tears through the back of the plane. The pilots look at each other. Something is very, very wrong. Oxygen masks drop. The cabin fills with fog. Passengers are screaming, gripping their armrests, writing final messages to their families on the backs of napkins and boarding passes, because deep down, they already know. In the cockpit, the captain pulls back on the control column. Nothing happens. He turns the wheel left. Nothing happens. For the next 32 minutes, 3 men will fight harder than almost any pilots in aviation history, against a plane that has completely stopped listening to them. What happens next will kill 520 people. It remains, to this day, the deadliest single aircraft disaster the world has ever seen. This is the story of Japan Airlines Flight 123. It's August 12th, 1985. A Friday evening, the start of Japan's biggest holiday weekend of the year. Obon, when millions of people travel home to be with family. Haneda Airport in Tokyo is packed. Japan Airlines Flight 123 is a Boeing 747, tail number JA8119, a short domestic hop to Osaka, barely 50 minutes in the air. 524 people are on board. Businessmen heading home for the weekend, families with small kids, a famous Japanese singer named Kyu Sakamoto, known worldwide for his song Sukiyaki. Nobody on this flight thinks twice about it. It's routine, it's short, it's safe. At 6:12 p.m., the aircraft lifts off the runway and begins its climb. 12 minutes later, at 18,000 feet, everything changes. There's a loud bang from the rear of the aircraft. Passengers later describe it as sounding like a bomb going off. The cabin depressurizes instantly. Oxygen masks drop from the ceiling, and somewhere behind the cabin wall, in the tail section of the plane, something catastrophic has just happened. Something the pilots cannot see, and at first, cannot even understand. Here's what actually happened, second by second. The explosion wasn't a bomb. It was the aircraft's rear pressure bulkhead, the dome-shaped wall that seals the pressurized cabin from the unpressurized tail, tearing apart under the strain of thousands of flights worth of stress. And when that bulkhead failed, it didn't just cause a loss of cabin pressure. The force of the air rushing out ripped off most of the vertical stabilizer, the tail fin of the aircraft, and destroyed all 4 of the plane's hydraulic lines. Now, on a normal day, losing one hydraulic system would be a serious but manageable problem. This aircraft had 4 separate redundant systems, specifically so that a single failure could never take them all down at once. Boeing engineers considered a total hydraulic failure so unlikely that they didn't build the 747 with a backup plan for it. Flight 123 lost all 4 at the same time. Without hydraulics, the pilots had no rudder, no elevators, no ailerons. In simple terms, the control wheel and pedals in the cockpit were no longer connected to anything that could steer the plane. They were flying 524 people in a 747 with absolutely nothing to fly it with. So what do you do when the plane refuses to listen? Captain Masami Takahama and his crew did the only thing they could. They started using engine thrust, increasing power on one side, decreasing it on the other, to try to nudge the aircraft's nose left or right. It's an almost impossible way to control a jumbo jet, and pilots don't train for it because it's not supposed to be necessary. But for the next half hour, that's exactly what these 3 men did, fighting a plane that was oscillating wildly, climbing and diving, rolling from side to side, completely at the mercy of physics. Air traffic control offered to divert them to the nearest airport. The crew tried. They couldn't turn. They tried Haneda, back where they took off. They couldn't line up. The aircraft was barely responding to anything they did. For 32 minutes, the cockpit voice recorder captured something extraordinary. Not panic, but discipline. The flight engineer calmly reading out altitude and speed, the captain repeating power, power, as he tried to control their trajectory with the throttles alone. At one point, they briefly regained a measure of control using this thrust technique, enough that for a few minutes, it almost looked like they might make it. They didn't. At 6:56 p.m., Japan Airlines Flight 123 struck a ridge on Mount Takamagahara in the mountains of Gunma Prefecture, northwest of Tokyo. The impact and the terrain made the crash site almost impossible to reach. It took rescue teams hours to even locate the wreckage in the dark mountainous forest, and that delay would become one of the most painful and debated parts of this entire tragedy. Of the 524 people on board, 520 died. Only 4 survived, including a young flight attendant who was found, incredibly, still strapped into her seat, thrown clear of the main wreckage. To this day, JAL-123 remains the deadliest accident involving a single aircraft in aviation history. So how does a modern jumbo jet lose every single hydraulic system at once? The answer isn't a design flaw, it's a repair. 7 years earlier, in 1978, this exact aircraft suffered a tail strike. The rear of the fuselage scraped the runway during a hard landing, damaging the aft pressure bulkhead. Boeing technicians were sent to repair it. And this is where everything went wrong. The correct repair procedure called for a doubler plate, a reinforcing patch, to be riveted on using 2 full rows of rivets, distributing the stress evenly across the repair. But the technicians made a critical error. Instead of using 2 rows across the entire patch, they used 1 row across part of it, and stopped the second row short. It looked structurally sound. It passed inspection. Nobody caught it. But that repair was now weaker than it needed to be by design. Every single flight after that, every takeoff, every climb to altitude, every pressurization cycle, put stress on that weakened section of metal. Investigators later calculated the repair could safely withstand roughly 10,000 pressurization cycles. Flight 123 was on its 12,319th cycle since that repair. The metal had been fatiguing silently for years, invisible from the outside, invisible to routine inspection, until it simply gave way at 18,000 feet with over 500 people on board. This crash forced the aviation industry to confront a hard truth. A repair error, one that seems small on paper, can sit dormant for years before it becomes catastrophic. It changed how Boeing documents and audits its own repair work. It changed how airlines like JAL cross-check maintenance records against manufacturer specifications, not just once, but repeatedly over an aircraft's lifespan. And crucially, it proved that redundant systems aren't truly redundant if a single structural failure can take all of them out simultaneously. A lesson that directly influenced how later aircraft, including future 747 and 777 models, physically separated and shielded their hydraulic lines from each other. But there's a second tragedy inside the story, one that has nothing to do with engineering and everything to do with what happened after the crash. The aircraft went down at 6:56 p.m. It wasn't reached by rescue teams until the following morning, more than 14 hours later. Local residents reported seeing the crash site glow that night. A U.S. Air Force cargo plane, and later, a helicopter crew from Yokota Air Base, spotted wreckage within the hour and offered to assist. Japanese authorities declined the help, citing jurisdiction and the difficulty of coordinating a joint operation in the dark, mountainous terrain. To this day, there is ongoing debate, supported by some survivor accounts and medical assessments, about how many of the 520 who died might have survived their injuries if help had reached them sooner. It's a question that has never been fully answered, and one that still shapes conversations in Japan about disaster response coordination decades later. Japan Airlines Flight 123 wasn't caused by bad weather. It wasn't pilot error. It was a single misaligned row of rivets in a repair job on a jet nobody thought twice about, sitting quietly for 7 years and 12,000 flights, until physics finally ran out of patience. If you found this story as unbelievable as I did researching it, hit that like button and stick around, because on this channel, we covered the flights, the failures, and the decisions that changed aviation forever. Subscribe so you don't miss the next one.